Hello grade 11 A-level students. Right now I'm going to explain the continuation of the reaction of benzenes. Now we are in subchapter 25.4. In the previous chapter and the previous subchapter of this arenes chapter, we had learned about the chlorobenzene and then also the bromination of benzene, the substitution rules for benzene. Now specific to halogenoarenes or halogenobenzene. We saw on previous page how bromobenzene and chlorobenzene can be made from benzene molecule. The reaction of the ring of halogenobenzenes are similar to those of benzene. Halogenoarenes undergo electrophilic substitution and can be nitrated, meaning nitrate electrophile can be introduced into the structure of halogenoarenes. This one, unlike halogenoalkanes, halogenoarenes cannot be hydrolyzed, even by boiling in aqueous sodium hydroxide. Let's revisit a little bit about halogenoalkanes from AS level chapter. When halogenoalkanes undergo hydrolysis with sodium hydroxide, the products are alcohol and hydrogen halide. This one in halogenoarenes cannot be hydrolyzed because the carbon-carbon bond is stronger in halogenoarenes than it is in halogenoalkanes due to the overlap of pi bonding system, similar to that in phenol. In addition to this, carbon attached to the halogen is not accessible to the usual nucleophile reagents that attack halogenoalkanes. Since its dipole positive charge is shielded by the negative pi cloud of the ring, this means that halogenoarenes are inert to all nucleophiles. Certain halogenoarenes find important uses as insecticides and herbicides. Okay, the application of halogenoarenes can be used as insecticides and herbicides. The example here, chlorobenzene used to make in large quantities as an intermediate in production of insecticide DDT. We know where the DDT is usually used. The use of this one insecticides is now banned in many countries. These compounds are quite inert to biodegradation. It means that it cannot be degraded, even using microorganisms. Why? Because there are two structures of benzene. These benzene structures make an overlap pi bonding system with the Cl and with the CH that makes difficult to break down. The only breakdown could be use high temperature and high pressure. When an insecticide is sprayed into the environment, how can the environment is heated under high pressure and high heat? It is very impossible. This one, what the other characteristic of these insecticides is they are soluble in fats and oils. So their carrier must be oil and fat, cannot be in water. And then they tend to concentrate in the fatty tissue of animals, usually in higher up the food chain. And then this one, DDT may still be used in parts of Africa and Asia to control the malaria mosquito, as the advantages to human health considered to outweigh the disadvantage to the environment. So it can decrease the amount of the victim of malaria. And then herbicides. The compound 2.4 dichlorophenoxyethanoic acid, or called 2.4-D and 2,4,5 trichlorophenoxyethanoic acid, short form 2,4,5-D, have been successfully used for many years as selective weed killers for broad-leaved weeds. They have little effect on narrow-leaved plants such as grass and cereals, so can be used as lawn or field weed killers. So the action is similar to the indole of ethanoic acid. As you can see here, the herbicides and also insecticides, they contain the same structure. It is benzene. We know benzene is insoluble in water because it has strong van der Waals forces, and the pi bonding system that makes it require high amount of energy to break it down. So we know that this insecticides and herbicides is poisonous to human. It is strongly carcinogenic, teratogenic, and mutagenic. This we know that most of the poison contains benzene structure, which is difficult to decompose, different from organic acid. We know one organic acid can be used to poison someone, but that organic acid easily decomposed in the environment. And then now we are reached 25.5 about phenol. Phenols contain two functional groups, hydroxyl group and benzene group. There is a nomenclature. If the only other groups on the benzene ring are halogen atom, nitro, amino, or alkyl groups, the compounds are named as derivatives of phenol itself. There is an example here. So 4-methyl-phenol, 2-nitro-phenol, 2.4 dichlorophenol. Why this one is consistent with the data booklet in A-level. So the first functional group is OH. That's the reason the name is phenol. When there is phenol, the other incoming group will be in the position of 2 or 4. This is the X group. The incoming will be in position 2 or 4, just like in this one, position 2 or 4, 2, 4. Okay, next, this one, reaction of the OH group. The CO bond in phenol is very strong. Why is it very strong? The CO here, the C refers to the pi of the part of the benzene. It has overlap pi bonding system with the O. That makes strong bond between the benzene and the oxygen. That makes the hydrogen easy to lose, easy to be donated. That makes the phenol is a weak acid. Why it is weak acid? Because it contains a low amount of Ka value, acid dissociation constant. Okay, so when hydrogen is donated, separated from the phenoxide, this negative charge is delocalized in around the structure of the phenoxide ion. Next, this is the delocalized phenoxide ion, all become negative charge. Consequently, phenol not only reacts with sodium metal, it giving off hydrogen gas because phenol is an acid, so it has property of acid. Acid reacts with metal to give hydrogen gas. Acid reacts with sodium hydroxide to produce salt and water. Okay. Phenol is visibly acid. pH of 0.1 in water is 5.4. So it will turn universal indicator solution into yellow. The other name of phenol is carbolic acid. And then now esterification of the phenol. Phenol cannot be esterification cannot undergo esterification, only use carboxylic acid. It must use stronger type of carboxylic acid or the derivative of carboxylic acid. It is called as acyl chloride. Why is it acyl chloride? Because the H here will be removed out, and then the H and then here the C double bond O, the electron of the C here is being taken by the chlorine. So the chlorine will separated become CH3C double bond O positive and Cl negative. This hydrogen positive with Cl negative will become HCl. This one CH3C double bond O negative and positive CH3C double bond O positive reacts with the phenoxide ion to become an ester. Name is phenyl ethanoate. Okay, next the substitution reaction of the benzene ring. As mentioned here, there is a nitration. Nitration, when treated with dilute nitric acid, no sulfuric is needed. Phenol give a mixture of 2.4 nitrophenols. So, how to introduce nitrate into the phenol? Using dilute aqueous nitric acid. In order to make the benzene has nitrate ion only, it must use concentrated nitric acid and concentrated sulfuric acid, but in this one it's not. Okay, 50% in here, 50-50 means these two, portion 2 and portion 4, most likely to occur. So the condition is at room temperature. Now the this one, the bromination. Phenol decolorize dilute solution of bromine water at room temperature. So this is the observation. Decolorize the bromine solution, giving a white precipitate of 2.4.6 tribromophenol. So the observation decolorize bromine water. Second observation, the formation of white precipitate. This again, no aluminum bromide is needed. No Friedel-Crafts catalyst is needed because the phenol itself is already reactive. So whenever there is bromine, it will react with the bromine. And then similar product formed by the action of chlorine water on phenol, because the phenol itself is already reactive. Okay, now coupling reaction. Coupling reaction comes from the word couple. So it means there are two benzene structure. One contains nitrogen and this one contains phenol. This one is an important azo dye, the coloring, the fabric coloring. This one, the reaction is using aqueous sodium hydroxide at 5 degrees Celsius, because if at high temperature there would be no reaction. The reaction would be not as expected. And then now the specific test for phenol. When a dilute solution of iron trichloride is added, so iron Friedel-Crafts catalyst is added to the solution of phenol, colored complex is formed. So the observation is colored complex is formed. The color depends on the substituent in the ring. With phenol itself, a purple coloration is observed in here. So the observation is purple color form. And then now important phenols. Important phenols are the applications of phenols in our daily life. A dilute solution of phenol in water called carbolic acid was one of the first disinfectant to be used in medicine. So phenol can kill or make the bacteria, microorganisms to die. If it is used in excessive amount, it will not only kill the microorganisms but might kill the person. Okay. Next, they are used much lower concentration, which reduces their corrosive effect. The two of the most common are TCP and chloroxylenol. Thymol occurs in oil of thyme, is an excellent non-toxic antiseptic as well as being fungicide. So this one is the organic fungicide, thymol. The name is thymol. This is also an antiseptic. Okay, see the structure. This one, the structure of chloroxylenol, or we know it nowadays as Dettol. Dettol solution contains chloroxylenol. And this one, there is a 2,4,6 trichlorophenol and then thymol. And then can be used for analgesic, contains benzene ring. The example is salicylic acid. It is which causes the vomiting and bleeding of the stomach. And then also the salicylic acid, the derivative, can be used for aspirin. Aspirin is for when we have headache, we usually take an aspirin. So if too much use of medicine is not good at all, because we know that benzene ring is very difficult to decompose. Aspirin is most widely used of all analgesics. However, it still retains some of the stomach irritating effects of salicylic acid. A less problematic painkiller is paracetamol, which is another phenol. So this paracetamol is containing benzene and hydroxyl phenol. Okay, the last part of this arenes, preparing arenes and phenols. Benzene and methylbenzene are formed during the cracking and reforming of fractions of distillation of crude oil. So In grade 10, you learn about the cracking of petroleum will produce short chain of alkenes, and possibly hydrogen gas. So in here, we know more details about the cracking and reforming fractions from the distillation of crude oil. Benzene can be produced. So the second, the hydroxyl group of the phenol can be introduced onto an arene ring by the following sequence. So this one using concentrated become this, and then this one undergo reaction with thin and strong acid. It will, so the NO2 will become NH2, and then NH2 react with sodium nitrate plus HCl at 5 degrees Celsius, then boil in water, it will become phenol. So this is the sequence of the reaction. In order to convert from nitrophenol into to convert nitrobenzene into phenol through phenylamine. Okay, this is the last part of this chapter, arenes.